So my name is Dean Yam from Technical Marketing here at VMware. I am joined by my colleague, Prashant Damdare from Engineering, and we're going to kind of tag team this. I'm going to cover some slides up front, pass it off to Prashant for some about 9 slides, and he'll pass it back off to me for some best practices, use cases, and some performance. All right, so welcome to VMware Fault Tolerance, Best Practices, Usage Scenarios, and Performance. So with that, let's get started. Disclaimer slide, I'll give you 1 second to read that. Okay. Agenda. So first I'm going to talk about the business continuity solutions and what it means to VMware. And then I'm going to pass things off to Prashant, and he'll describe what fault tolerance is and how it works. And then he'll cover some of the requirements on the software and hardware side of things for fault tolerance. And then he'll pass it back to me. I'm going to talk about some of the enhancements we did for 4.1, vSphere 4.1, which was released recently. And then I'll cover some best practices and usage scenarios, and then follow that by performance. And then I'll show you some additional resources as well. All right? So the power behind VMware's business continuity and disaster recovery solutions is really in how we layer our different protections. At every level of the data center, from individual components all the way up to the entire site, we offer protections for both unplanned and planned downtime. All right, so let's just quickly review these protections starting from the left. So there's a lot of high availability features already built into ESX Server itself. ESX has long been recognized as a platform that delivers in the highest in reliability. So let's go and see, take for example, a high availability feature already built into ESX called NIC teaming. So with NIC teaming, each networked virtual machine uses onboard NICs that are grouped together for higher throughput and greater redundancy. All right, a user can specify different configurations to configure multiple active and multiple standby NICs, and these can be different. You can have different NIC teaming configurations for different port groups, even if they're on the same virtual switch. Another feature that's built into ESX already is called storage multipathing. Now, this is the ability to protect against path failures from your ESX server down to the storage. So moving over to the left or to the right. We have other availability features, high availability, VMware HA. This was actually introduced in VMware Infrastructure 3 back in 2006. And I'll talk a little bit about how that works in the next slide, and I'll talk about the differences between HA and FT in the next slide as well. Also, vMotion, VMware vMotion. This lets you take a running virtual machine and migrate it while it's still running from one ESX host to another ESX host without any kind of data loss or interruption to the workload. And this is useful for planned downtime. If you ever want to move virtual machines away from a physical host, a physical ESX host, to perform maintenance on it, you can use vMotion for that. And also DRS, Distributed Resource Scheduler. So this is also used for planned downtime in that we have a feature called maintenance mode. You can put any ESX host into maintenance mode, and that'll kickstart DRS. And DRS will evacuate all of the running VMs off of that ESX host to other healthy available ESX hosts in your DRS cluster. Then you can bring that host into maintenance mode, perform the maintenance operations such as upgrading memory or whatever, and when it's ready, you bring it out of maintenance mode. Now this becomes a newly available host in your DRS cluster. DRS will kick in again and repopulate that newly available ESX host. Now moving over to the storage side of things, we have another feature called VMware Storage vMotion. So similar to vMotion, this lets you take the VMDK files of a VM and migrate them from one data store to another data store, all while the VM is still running without any kind of data loss or interruption to your service. So this is really for, again, planned downtime. If you want to perform any kind of maintenance to your data store or your disk arrays, you can use Storage vMotion for that. And then over to the right, we have a lot of data protection features. VMware Consolidated Backup plus third-party backup solutions that let you take full image backups of your VMs, as well as a new feature we introduced last year with vSphere 4 called vCenter Data Recovery. And finally, on the site side of things, we offer protections of an entire data center site, letting you fail over from data center A to data center B, and also vice versa using SRM, or Site Recovery Manager. So all the features I just mentioned fall under one of 2 categories, planned and unplanned downtime. So with planned downtime, we really achieve that through workload migration. I already touched upon all these features. We have vMotion, Storage vMotion, as well as DRS. That's kickstarted when you enter a host into maintenance mode. So on unplanned downtime, that's where the focus of this talk is in a feature called fault tolerance. Fault tolerance is actually an extension to high availability. I'll describe the differences in the next slide. In addition to those two, we have vCenter data recovery I mentioned, VCB, SRM, and all those availability features built into ESX server itself. All right, so VMware HA, or high availability. How that works is when you have a VMware cluster, a cluster is just a collection of ESX hosts. You can enable that cluster with HA, and when doing so, it protects all the running VMs sitting inside that cluster with HA, so that when any ESX host fails, all of the running VMs on that host are automatically restarted on other healthy available hosts in the HA cluster. Okay, so that's been great. There's been about 90% of our customers are using that feature in production. However, it does have a little bit of downtime in that it requires time for you to restart that VM on another host. It could be anywhere from 1 to a few minutes, okay, depending on the OS. With FT, we've actually extended the capabilities of HA with a new feature called VMware Fault Tolerance, which we introduced in 2009 last year in vSphere 4.0. And what that lets you do is protect your VMs in an HA cluster without any kind of downtime or any interruption to your service. And we achieve that by creating a shadow secondary copy of a VM which you enable with fault tolerance and migrate that secondary copy on another host in your HA cluster. And those two are paired up and put into lockstep synchronization so that if either one of those copies were to fail, the other one immediately makes up for it. So you have no downtime and no data loss. All right? So with that, I'm going to pass things off to Prashant, and he'll talk about how HA works, or how FT works, sorry.
All right. Thanks, Dean, for the excellent big picture and the business continuity. Now let's dive deep and try to understand how fault tolerance helps you achieve near zero recovery time objective. So before I start, I just want to ask you a couple of questions. How many people in this room have used FT before? Can you please raise hands? How many people are not using fault tolerance because we do not support multiprocessor VM? Good. So those who are not using fault tolerance because we don't support multiprocessor VM, and even those who are using FT, we are interested in talking to you. And this is a good chance to influence the product roadmap. So please either drop your visiting card or collect mine and drop me a note, and one of our product manager will get back to you. We are interested in talking to you regarding multiprocessor fault tolerance. Just to make things clear, we do not support multiprocessor fault tolerance as of today. We are working on it. It's still part of the future release, and I can't tell you when. Yeah, just setting the expectations right. So here's a kind of an overview in a pictorial format. So fault tolerance create virtual machine pairs that are running in a lockstep and essentially mirroring the execution state of a VM from one host to another. In this case, my primary is running on the leftmost host, my secondary, the grayed out box, which is my secondary, we also call it a shadow VM. And these two VMs are running in a lockstep, exchanging some information over the FT logging network, which is indicated by a green arrow there. So to the external world, they appear as one instance, but they are really fully redundant instances. If one of the VM fails, the other VM is immediately going to take over. For example, in this case, if the primary VM fails, the secondary immediately takes over. And it does so without any loss of data, without loss of transactions or network connections. In fact, the failover is at the instruction boundary, so you don't really lose anything. And most importantly, the failover is transparent to the user. No manual intervention is involved here. So let me replay that animation again. So if you noticed, the other VMs running on the failed host were automatically restarted by HA. So the FT VM was restarted, sorry, it's not restarted. Secondary immediately took over when the primary failed, and the other VMs running on the failed host were automatically restarted by VMware High Availability. So this is kind of an overview. Couple of points I want to emphasize in this overview slide is, first, it's really easy to use. Unlike other clustering products, you don't need to do any complex settings or complex configurations here. And most importantly, FT is OS and application agnostic. What I mean by OS and application agnostic is, you don't have to install any patches or drivers in the guest operating system. You don't have to modify your workload to make use of fault tolerance. It's just ready to use. You don't have to modify anything in your virtual machine to make use of fault tolerance. So let's see some more details about how this thing works. So here I have an example where I have 3 hosts running in the HA cluster. My VM is running on the leftmost host. So when I start FT on this VM, I'm going to create a secondary. So the secondary is created using modified form of the vMotion. So the primary and secondary are running. They're continuously monitoring each other by exchanging heartbeats over the FT logging network, which is again indicated by the VMware FT arrow here. And the primary and secondary are identical, almost identical. So if you open a console to the primary and if you move a mouse, if you open a console to the secondary, you will see the exact same mouse movement in the secondary. So we call it as a mirrored execution. The execution of a primary is mirrored over second host, we call it as a secondary. But the important point here is primary is running, talking over the network, secondary is quiet, kind of a silent partner of the primary. So it's the primary VM which is interacting with the outside world. Secondary is quiet, it's a silent partner, it's not running. It's running, but it's not talking over the network. It's not writing to the disk. It's not sending an output to the outside world. So if one of the VM fails, the other VM is immediately going to take an action. For example, in this case, if the leftmost server fails, the secondary is immediately going to take over. So from a user standpoint, it looks like a vMotion, but much, much faster. It's instantaneous. So secondary takes over immediately. The user won't even notice. Just to give you an example, if you have an RDP session inside the primary, you won't even notice that failure or a failover. RDP session will simply continue to work. It's transparent to the user. The failure and failure are completely transparent to the user. It's all automatic. And we take this step further. We automatically restore the redundancy. So what's going to happen is VMware high availability will kick in. We'll try to find another host, in this case third host, and we'll automatically start the secondary. So your VM is again reprotected. So till the time your secondary started, the FT status is going to be unprotected. The important thing you want to note here is it's all automatic. There is no user intervention involved here. So the failover was automatic. Reprotection, that is finding another host to start a secondary, was also automatic. Certainly you have to enable DRS to make that happen. So the important point I want to emphasize here is the failure or a failover and starting a new secondary does not involve any vCenter involvement. Basically, you don't need to have a vCenter running for a failover to work or for secondary to start. Another thing I want to emphasize here is a split brain situation. We handle split brain, but I will talk about split brain in the next slide. So this is the most important slide. This is the crux of the FT. So I'm talking about mirroring and lockstep. Now I'm going to talk about how that mirroring and lockstep actually works. So FT is developed using a technology called as record replay. And we are shipping this record replay technology with another VMware product called as Workstation for a while. So what is record replay? So what we do is, in this particular case, the VM on my left, that is the primary VM, the operations are carefully recorded and transmitted to the VM on the right. We call it as a secondary VM or a shadow VM over that FT logging network. The most important thing here is we do not record everything. So if you record everything, including all memory accesses, it's going to be a huge amount of data. We only record non-determinism. And what I mean by non-determinism, we only record inputs. So the notion here is, let's say you have a program running on a processor which does not accept any inputs. Then that program is always going to run same. It's always going to produce same output. But if the program is accepting user inputs, depending upon the inputs, the program's behavior is going to change. And what we do is, we catch these inputs on the primary, we feed them to the secondary at the exact same point to get exact same output. So the non-determinism is basically introduced by inputs. And what I mean by inputs is, input could be user input, like keyboard or mouse. It could be interrupts, like network. It could be disk I/O. And sometimes the operations on the processor itself, like read timestamp. So we record all these non-determinism, feed it to the secondary at the predefined choice points to get exact same output. This is how we achieve mirroring or record replay in a nutshell. We can talk about entire day for about record replay. It's a pretty neat technology. Those who are interested, I can share some white papers with you guys. Just meet me after the talk. it's a complex technology. It's impossible to achieve in the physical world. It's not that easy, but it's doable in the virtual world. I will take questions on the record replay after a few slides. So the other thing I want to point out here is a shared disk. Both the primary and the secondary are sharing the same virtual disk. And this is the shared disk which help us to solve the split brain problem. Now let me define the split brain problem here for those who don't know. So split brain is a situation where both the hosts are running. So your primary is running on one host, your secondary is running on another host. Both the hosts are running fine. If you lose a network connectivity between these two hosts, then the primary is going to think secondary is dead, secondary is going to think primary is dead, and both VMs will try to become primary. And you certainly don't want to be in a situation where there are two VMs with the same identity, that is same IP address, same MAC address, running on two different hosts exactly at the same time. And we prevent this with the help of a shared disk. So after the failover or during the split brain, whoever wins the race takes immediate control of the disk. And VMware FT guarantees that only one VM will survive to be primary. So we guarantee you will never end up in a situation where there are two primaries running on two different hosts with the same identity. So in a default configuration, secondary is never going to read from a disk. All the I/O traffic is going over the FT logging network. Primary is going to record all the disk I/O and going to send to the secondary over the FT logging network. And of course, secondary never writes to the disk. Secondary never communicates over the network. As I said before, it's silent. It is a quiet, silent partner of the primary. It never communicates with the outside world. And disk and network is outside world for a secondary VM. So by default, secondary never writes to the disk, and all the reads are actually sent over the FT logging network. So FT has some hardware requirements. For CPU, it requires hardware virtualization to be enabled, and make sure hardware virtualization is enabled in the BIOS, because most of the time it's disabled. And most of the processors in the market these days have hardware virtualization enabled. So you don't really need to worry about the host CPU. Most of the processors in the market support hardware virtualization. The only thing you have to make sure it's enabled in the BIOS. Shared storage is a requirement, and we support any shared storage architecture, that is fiber channel, iSCSI or NAS. Another piece of hardware which is required is FT logging NIC. This is the link which helps to keep two VM in sync. And we highly advise you to have a separate vMotion NIC and a separate FT logging NIC. And each is of the capacity at least the 1 gigabit Ethernet. Your host should be part of the HA cluster, as I showed in the example, because that HA and FT works together pretty well. In case one of them dies, HA is going to help you find another host in the cluster to start your secondary. So this is a strict requirement, and we say your FT host must be part of the HA cluster. And lastly, your FT host should have the same FT version. And this is pretty straight, like they're running in a lockstep. Primary and secondary are running in a lockstep. They're exchanging events over the FT logging network, and they need to speak the same language, and hence the FT version requirement. So the FT version for both the hosts has to be same, because they need to understand each other. Just a side note, Dean already mentioned 90% of the people are using HA in production. FT is the highest adopted feature as of the last release, so 20% customers are using FT in production right now. We support all guest operating systems which are supported by ESX. And I will repeat, FT is OS and application agnostic. You don't have to install any patches or drivers in the guest operating system. You don't have to modify your workload to make use of fault tolerance. It's OS and application agnostic. Strict requirement, as I mentioned in the beginning, we only support uniprocessor virtual machines. We do not support multiprocessor as of today. So before you enable fault tolerance, make sure you have only one virtual CPU, otherwise it will fail to enable fault tolerance. Virtual disk should be fully allocated. We call it as a thick. So note that virtual disk, I'm talking about virtual disk here. Your physical device or your physical storage can be thin provisioned, but your virtual disk must be fully allocated. And you don't need to worry about this requirement. So when you enable fault tolerance, Virtual Center will take care of this requirement. Virtual Center will, if your disk is not fully allocated, virtual center will convert it and make sure it's fully allocated. So it's pretty much transparent to you. Your virtual machine should not have non-replayable devices like physical CD-ROM and physical floppy drive. And as you know, these devices doesn't make sense on the server VMs. No one uses physical CD-ROM or floppy drives on the server VMs. And most importantly, these devices certainly doesn't make sense on the fault-tolerant VMs. Just imagine, like, if your VM is reading from a physical CD-ROM or physical floppy drive, and for some reason it crashes, the secondary VM is going to take over, and secondary VM won't have access to this physical CD-ROM and physical floppy drive. So certainly these devices doesn't make sense, especially on the fault-tolerant VMs, and for that matter, even on server VMs. And we highly recommend you to update VMware tools. So you may not know your servers may be FT ready. To confirm, you can use this tool called a site survey. So this is a free tool, can be downloaded from the link mentioned on the slide here. It does not require an FT license. As of last release, it's integrated as a plugin in the virtual center, really easy to use, can run on a single host or can run on a multiple host. It can also run on a group of clusters. And it generates a very comprehensive report for the IT admin. I'll just give you an example. So let's say you have two physical hosts running in a two different cluster, and they are FT compatible. And you have a VM, which is a single processor and satisfies all the hardware and software requirements. This site survey will tell you, if you put these two hosts, which are there in a different cluster right now, if you put them in the same cluster, you can enable fault tolerance on a particular VM. It generates a very comprehensive report for the IT admins. And another tool which complements site survey is part of the vCenter. So this checks if your cluster is FT compliant. So it does some basic precondition check like, do you have the FT logging NIC? Do you have the vMotion NIC? Do you have two hosts which are fault tolerance capable, etc. In addition to these hardware and software requirements, I want to emphasize on one more point here. Your VM and your workload is protected using fault tolerance. But you have to make sure your environment is highly redundant. What I mean by your environment is highly redundant, you shouldn't use fault tolerance in an environment where there are other single point of failures. So you should make sure right level of redundancy at the storage and network layer. So as Dean mentioned in the beginning, you can use NIC teaming for network redundancy. You can use storage multipathing for storage redundancy. The idea here is you shouldn't use FT in an environment where there are other single point of failures. So how hard it is to enable fault tolerance? Simple click is what you need. Within seconds, we'll create secondary VM and you're protected. So fault tolerance is just a VM property. There is no magic. It's just one right click and you're all set to use fault tolerance. Obviously, you have to make sure you have the FT logging NIC, you have the FT compatible host, and you have the necessary hardware in place. Let's take a step back and talk about some basic functions on fault-tolerant VM. So when you power on the primary or when you power on the VM, which is fault-tolerant VM, we will automatically create a secondary with the help of vMotion. If you have a DRS enabled, DRS will automatically place or will give you a recommendation to place your secondary VM. In fact, if you have DRS and EVC stands for Enhanced vMotion Compatibility. If you have DRS and EVC enabled, it will automatically place your primary as well. So if the DRS and EVC is enabled, everything is automatic. You just specify which VM is a fault-tolerant VM, and when you power on, it will automatically find a host to power on the primary. It will also find out another host to power on the secondary. It's all transparent to the user. If you power up the primary, it will also power up the secondary, which is pretty obvious. If you do a soft reboot, now see here, soft reboot is all inside the guest. So that soft reboot will be recorded and replayed on the secondary. So if you do a soft reboot on the primary, secondary is also going to reboot. Secondary is simply going to follow the primary and will also be rebooted. So FT VMs or FT workloads are not really very different from your regular VMs. They can still make use of features such as vMotion. In fact, you can migrate FT VMs online. And what I mean by migrate FT VMs online, even when the migration is in process, even when the vMotion is in process, your workload is still protected with the fault tolerance. So this gives you a great flexibility of moving your VM while your VM and workload is still protected. The caveat here is you cannot migrate both primary and secondary at the same time. You have to migrate only one at a time. But that's okay. You can migrate, whenever you migrate a FTVM, you are protected. That's more important. Another important caveat here is we do not support migrating, we do not support storage vMotion on online FTVMs. But of course, you can disable fault tolerance, which is just one click, do the storage vMotion operation. Note that your application is running when the vMotion is in progress, when the storage vMotion is in progress. And when the storage vMotion is over, you can re-enable FT with just one click. It's pretty easy to use. And we go an extra mile to make sure user doesn't move primary and secondary on the same physical host. It doesn't make sense to have primary and secondary on the same host. What if that host fails? None of your VM is running. So the primary is running, secondary is replaying, secondary is following the primary. Primary and secondary are continuously exchanging heartbeats, and these FT heartbeats are faster than the HA heartbeats. If I recall correctly, the FT heartbeats are exchanged every 200 milliseconds, and we wait for 10 lost heartbeats, 10 continuous lost heartbeats to conclude that the other host is dead, which comes to approximately 2 seconds. So in case of a failure, you are going to wait for 10 lost heartbeats, that is 2 seconds, to conclude that the other host is dead, and then you will try to take over and will try to become a new primary. That's about single host failure. We also support some partial host failure. For example, if the storage on the primary is inaccessible, we will detect that situation, and the secondary will take over and will become a new primary. But note that this is not going to happen in 2 seconds. Identifying the storage is inaccessible by nature takes like 8 to 10 seconds, but we will detect that situation and secondary will take over. If both the hosts fail or if both the hosts crashed, the HA will kick in, HA will find another host to start your primary, and then fault tolerance will find another host to start your secondary, but you will be protected. The important thing here is, again, this is all transparent to the user. If you have a DRS and EVC enabled, this will be all transparent to the user. This will all be automatic. Fault tolerance does not protect you from software failure. So if you see a kernel panic on the primary, you will see the same nice kernel panic on the secondary. Yeah, because we are replaying. So if your OS crashed on the primary, we are replaying. So it's bug for a bug. So we will replay the same sequence and your secondary is also going to crash. But what's going to happen is HA will kick in. So HA looks at the OS health, and with the latest release, we have the application awareness. I believe Dean mentioned that in the beginning. We also look at the OS health and we look at the application health, and then in this case, we will know that the OS has crashed, so HA will restart your primary, which will also restart the secondary. So you'll be protected in this case by the VMware high availability. But the important point here is fault tolerance protects you only from hardware failures. So that's about FT. Before I hand over to Dean, who will talk more about best practices and performance, any questions on the FT? So DRS has different levels. You can set it to automatic, you can set it to semi-automatic, you can also set it to manual. With manual, yes, it's a hard affinity, but there is a way to specify the soft affinity as well, if I recall correctly, in a semi-automatic mode.
You can also pin microphone. Can you turn? Oh. Okay. You can also pin FTVMs to certain hosts. We have a new feature called DRS VM to host affinity. You can pin VMs to certain hosts. Okay. Question?
To protect the virtual center running in a VM. Yeah, sure. So his question is, my vCenter is running in a VM. Can I use fault tolerance to protect the virtual center, or can I use HA to protect the virtual center? Okay.
Right, so the question is what you do, Heartbeat or FT. So the recommendation right now is still Heartbeat. That's our product to protect vCenter. You can protect vCenter with FT, but our recommendation is to use 2 virtual CPUs to run your vCenter server. So in that case, Heartbeat is specifically geared to protect vCenter.
Can you repeat that? Sure. So the question is basically we are sending the execution of the primary VM to the secondary host or the FT logging NIC. So if I have insight into that FT logging tunnel, can I see the memory of the user? Can I see some important data there? To answer this question, the answer is yes. But the important point here is we do not record everything. We only record non-determinism. Like we are not recording all memory accesses. So you won't really see the contents of the memory. What we are recording is the interrupts and when that interrupt happened. We are recording the read timestamp and when it happened. So we are sending only that non-determinism over the FT logging network. Yeah, so you won't really see the usernames and passwords over the FT logging NIC. Yeah.
We don't enable any specific encryption on that data going over the network.
And they're part of the same subnet, so they're pretty secure, right?
There's a question here. Oh, sorry, he's... So we are working hard on that, and it'll be available in a future release. I think this gentleman had a question.
Yeah, so I was thinking possibilities in terms of, let's say, for why they have a remote data center and why they have another VM and stuff. Do you guys ever support asynchronous type login? So this way, let's say I have a sector that lost in 35 minutes, and why they have it asynchronous, I would do performance on the asynchronous.
That's a good idea. But right now, so these machines are running in a lockstep. So delaying the secondary is going to slow down the primary. So when you say 5 seconds or 5 minutes, you have to delay. Yeah, we can think about it, but right now it's not supported.
Right. There are some, right now it's not supported, like Prashant said, there are some bandwidth requirements. I'll talk about that in a minute.
So I'll take one question and then we'll hand over to Dean. I'm sorry, we can't talk about future releases and future products here.
So we are working on that, and it'll be available in a future release.
Just to you guys give a sense, like it's a complex problem to solve. Maybe the same solution may not work for multiprocessor. It will need a fundamentally different approach to solve this problem, and may have some strict hardware requirements as well. If you're really interested, either collect my card or drop me a note, and we should talk more. If you have NDA signed, I'm sure our product manager is interested in talking to you. So meet me after the talk. We'll talk in more detail. Over to you.
All right. Thank you, Prashant. Hopefully you got a good understanding of what FT is and how it works. All right, I'm going to move on and talk about, first I'm going to talk about the enhancements we did for vSphere 4.1, and then I'll cover some usage scenarios followed by best practices and some performance numbers that we came up with. All right, so we released vSphere 4.0 a few months ago, and we really worked on some fit and finishing enhancements with FT specifically. Now, the first one Prashant touched upon a little bit in that we now fully support DRS with VMware FT, so they're fully integrated. What that means is prior to 4.1 with 4.0, DRS understood the resources that FTVMs used in terms of the memory and the CPU utilization, but it did not automatically load balance your FTVMs, the primaries or the secondaries. DRS will continue to migrate and load balance the non-FTVMs, but not the FTVMs. So with 4.1, we added support to allow DRS to fully automatically load balance your FTVMs as well as non-FTVMs. Okay, the requirement there is that enhanced vMotion compatibility is needed to be enabled, and this is to allow DRS for better decision making into where to place your FT primary and secondary VMs. The second point there is that we have a better versioning control mechanism that actually lifts the requirement that the ESX server running your primary the build of that has to match the ESX build running the secondary. All right, so prior to 4.1 with 4.0, those build numbers had to be identical. Even on top of that, they had to be patched to the same patch level. So with this new version control system, we've actually relaxed that requirement in that only the FT versioning has to be the same on the host running the primary and the host running the secondary. So so that is definitely a less strict requirement, and that the FT versioning doesn't always change as you update the ESX the server. And finally, we have better differentiation of events that were generated by the primary VMs versus the events generated by the secondary. Just simply a matter of better labeling of those events. And one more point that's not on the slide, and Prashant mentioned a little bit, is that we have now offered with 4.1 APIs for application awareness. So we basically enabled our ISVs to create solutions and applications that leverage those application awareness APIs to create solutions that actually monitor, discover any kind of health issue going on in the application within the guest OS, and also be able to remediate those applications by either trying to restart the application within the VM, and if that fails after a number of times, to actually restart the entire VM, which in turn also restarts the application within the VM. Okay, so just an example of two ISVs we're working with, Symantec and Neverfail. They have solutions out there that take advantage of our APIs for application awareness. All right, so some use cases. This one in particular is called FT. We call it FT on demand. Prashant mentioned that FT is basically a VM property that can be turned on and off at any time, assuming you have the right requirements underneath there. So let's take, for example, at the end of a quarter where the last few days are particularly stressful on your systems, and any kind of downtime could be more disastrous than during other times of the year. So you can set up a scheduling scripts where you turn on FT for those mission-critical VMs running mission-critical workloads for those last, let's say, 3 days of the quarter. And then when the new quarter begins, your script will automatically turn off FT. So you don't want to have FT turned on for all your VMs all the time, because it does take more resources. You know, you're using about double the amount of memory and double the amount of CPU to run these mirrored copies of the VMs. So you might just want to use them on those mission-critical times of the year. Okay, so this is a good way for you to protect during those times. Also, I'm going to go through a list of some of our target FT applications that we're seeing customers using. The most popular application is databases. All right, so this is the most common workloads that people are protecting with FT, and these are small to medium-sized databases that can fit on one virtual CPU. You know, of course, we're not saying all your databases, all your mission-critical production databases, you can't protect with FT because of the requirement of one virtual CPU. But definitely, there's those smaller, medium-sized, mission-critical instances that can. And most of these databases are SQL Server that we're seeing. Also, we have customers using Exchange and messaging and protecting those applications with FT, in particular BlackBerry Enterprise Server and Microsoft Exchange. One example is that we have a gaming company customer that's running 750 mailboxes on one FT VM. And they've been running this for a while, and they've reported no problems. Also, mission-critical web and file servers. So as you know, file servers, they might be stateless, but then there's applications that are using it that are very sensitive to the health and the uptime of the file server. And losing that file server could be very costly. So as an example, imagine a simulation, which is relying on a file server to do I/O to the disk. And a crash or downtime of the file server could basically wipe out your simulation. If your simulation has been running for 10 hours and a file server goes down, then you've basically lost 10 hours of compute time. Also, finally, we have a lot of customers running custom applications and specifically manufacturing custom applications. And basically, these workloads are mission critical in keeping production lines flowing, all right? And any kind of breakage or downtime in those production lines, that's going to result in loss of productivity, and you're going to lose material. So as examples, we have a customer that's a propeller factory, and imagine a propeller going down the assembly line being shaped and carved. Any kind of downtime to the system causes that process to stop, and basically they've just now lost an entire expensive propeller. Similarly, with a meat factory, meat is a spoilable product, and as that moves down the assembly line to be labeled and packaged, any kind of a stop in the flow will result in a loss of your meat. And finally, with the pharmaceutical companies, of course, if you have any kind of interruption to your production line, you don't want your customers getting the wrong pills, right? So, all right. So moving on, the next two slides describes two proof of concepts we did last year. The first one's on SAP, protecting that with FT, and the next slide talks about BlackBerry and protecting the BlackBerry Enterprise Server with FT. All right. So if you're not using SAP, some of this terminology may not make sense, but I think the concepts hopefully will be clear. So we did this proof of concept on the SAP ECC, which is an ERP Central Component 6.0 system, and this is based on their NetWeaver 7.0 platform. And a lot of customers deploy this system, which exposes a single point of failure, which is the module called the ASCS. This is the module that controls the message and transaction locking services. So if you have a failure of your ASCS module, basically all the users have lost their sessions to the database, they've lost the messaging, and all their locks go away, all right? So you definitely have interruption of service there. So what we did was we put the ASCS in one virtual CPU FT VM, and we protected that with VM, and we had about close to 1,000 users running a simulation benchmark. We basically had that running on a blade, pulled the blade out, and we saw no interruption of their messaging or locks, and no users lost their connections to the databases. Of course, there's also other modules in this SAP system, the application server and a database, but there's already protection mechanisms in place to handle failures of those modules. All right, the next one is about BlackBerry Enterprise Server. This was a proof of concept done on 4.1.6 last year. And the BlackBerry Enterprise Server, it is a single point of failure because it controls all the data going from your Exchange and databases to the BlackBerry devices. So if you lose that, all your devices lose their Outlook invites, their emails, all the data going to the endpoints there. So what we did was we protected the BlackBerry Enterprise Server in a one virtual CPU FTVM and ran many users on that. And we again pulled the blade out, and we saw no interruption in the flow of data to the BlackBerry devices. And based on Research in Motion's own guidance, a one virtual CPU VM running BES can support up to 200 users, each user sending 100 to 200 emails per day. Okay? All right, so let's jump ahead into talk about performance of FT. So FT really has little impact on throughput when the primary and the secondary FT VMs have enough CPU headroom, right? So the maximum overhead we're seeing in throughput is under 10%. Okay, FT introduces some latency for I/O, but the latency is really imperceptible for your typical real-life workloads. And the traffic generated by FT, it's really heavily dependent on the nature and the type of workload you're running in the VM. So what we're seeing is a 1 gigabit link of your FT logging network is sufficient for most workloads out there. And that's actually our recommendation, is to run at least a 1 gigabit per second link between your FT primary host and the secondary host. And for most of the workloads that we studied, their traffic across the FT logging network was less than 100 megabits per second, and I'll describe more about that in the next few slides. And finally, increasing the network latency between the two hosts running your FT primary and the secondary, it really has little impact on the throughput. However, if there are applications that are really latency bound, you may see a slightly greater impact. All right, so some best practices. A lot of the best practices for running fault tolerance really surround the bandwidth or the FT logging network, because that is a pretty critical component of allowing FT to work, and it could be a bottleneck if you're not careful. So for the FT logging network, it roughly requires per FT VM pair, so primary and secondary. We're seeing roughly 400 kilobits per second, plus any kind of incoming network traffic to the primary, as well as any kind of disk I/O that the primary is performing. All of that data is sent over the FT logging network to the secondary VM to be replayed. To follow on that, don't put too many FT VMs on the same host. So our recommendation is that with a 1 gigabit per second FT logging network, don't put more than 4 FT VMs on any given host. And if you put 4 on a host, make sure to mix them, two primaries and 2 secondaries. Mix the primaries and secondaries because most of the traffic is unidirectional going from the primary to the secondary. So to make it more balanced and more bidirectional, you just want to mix up your primaries and secondaries in the same host. And definitely consider a 1 gigabit logging network if available. Then you'll be able to increase the number of FT VMs on the host. Sorry? Consider a 10 gigabit network if it's available. So the minimum requirement the minimum recommendation is a 1 gigabit per second FT logging network. Sorry if that wasn't clear. And also we have a recommendation for the round trip latency between the FT logging network, and that should be a sub 1 millisecond round trip latency. Of course, if it's not a strict requirement, but if you have anything greater than that, you might just see the user will see a slightly longer pause in the workload, in the service, as a failover is occurring. All right, so let's talk about some example applications that we've tested FT on. Oracle and also SQL Server 2005. So with the Oracle 11G, we ran the swing bench benchmark, and we had 80 user sessions with a lot of random disk I/O with moderate network traffic. And what we see is that with FT enabled and FT disabled, the blue bar here is FT disabled, and the green bar is FT enabled. You're seeing not much of a difference in throughput. So very small difference in throughput there in terms of operations per minute. On the SQL Server 2005, we're running a DVD store benchmark, which basically simulates transactions of a typical DVD store. And we ran 16 client sessions. Each session was a thread. And what you see here is that with the blue bar with FT disabled, you're getting greater throughput than the FT enabled, but it's definitely less than 10% in terms of the overhead you're adding to the throughput in terms of operations per minute. Okay, so with the Oracle, the FT logging traffic was about 12 megabits per second, and the traffic for the SQL Server was 18 megabits per second, so well under 100 megabits per second for these types of typical workloads. All right, so now we're looking at latency and also CPU utilization performance. So we also ran some tests with a 10 gig VM with 10 gigs of RAM on Halem processors. And the overall effect was that the difference in latency was roughly 10 milliseconds. And there was a very small CPU utilization increase for your FT VM. So on the left side here, we ran load gen on Exchange. And we're seeing with 1,000, 1,500, or 2,000 users, the difference between the blue and the green, basically the blue is FT disabled, green is FT enabled. It's less than 10% difference. That's latency there. And also with CPU utilization, we also ran load gen on Exchange, and we don't see more than about a 1.5% difference in the CPU utilization. Note that the y-axis here goes from 0 to 8%. Okay, so not much of a CPU difference either. All right, so this is the last chart on performance, and there's a lot going on here, but I'll break it down for you. Basically, what we want to do is look at the performance of one virtual CPU versus a 2 virtual CPU VM. All right, of course, you can enable that one virtual CPU with FT. So what we did is we ran Exchange 2007 on a 1 virtual CPU FT VM on new Nehalem processor, Intel Nehalem, and a 2 virtual CPU VM on an older generation Intel Harpertown processor. And we looked at the latency and the CPU utilization here. So the first one I'll talk about is latency. If you notice that this blue bar here and this blue bar, those are the average send-mail latencies for Exchange 2007. And on the left here, the Nehalem is showing a latency very similar to the Harpertown processor. So what this means is that, well, we actually were running 1,500 users on this Nehalem 1 vCPU VM with FT enabled, and 2,000 users on a 2 vCPU VM, of course, without FT, showing similar latency. And what that means is on a per CPU or per vCPU basis, you're running 1,500 here versus 1,000 here. So we're seeing a 50% increase in the number of users we can support at the same latency with a newer generation processor running one virtual CPU. With CPU utilization, the highlight here is that the red line here, the red point actually here, running on Nehalem, we were using 2,000 users on a one virtual CPU with FT enabled, and we saw that the CPU utilization was about 45%. This basically means there's a lot of headroom to increase more users. So even with one virtual CPU, you can definitely account for peaks or spikes in your workload. So the takeaway here is that with MS Exchange 2007 and a one virtual CPU VM, it gives really good performance on Nehalem, and it can definitely take advantage of having FT protected. So that's really it. I talked about our new feature, which we introduced last year, called VMware Fault Tolerance. And vSphere 4 and 4.1, they really increase the availability of your applications. It's all about the application. So we have storage multipathing and NIC teaming on the server side, as well as all of our features, which help applications with availability, vMotion, HA, VCB, and SRM. And then also we've extended HA to fault tolerance, which lets you protect your VMs with no data loss and no interruption to your service. All right. So let's take some questions now then.
Sure.
There's some more resources. That I'm not sure.
So the question is, basically, if I'm using memory compression, how it will affect fault tolerance. Is that right? So fault tolerance is affected, the performance is affected only based on inputs and outputs. So memory, for CPU intensive workloads or for memory compression, it shouldn't affect. So the performance will decrease if and only if you are too much of incoming network packets or too many outgoing network packets, or if you're doing too much of a disk I/O. For CPU intensive workloads or for memory intensive workloads, you shouldn't see any performance issue.
Further concerns of fault tolerance with snapshots, is that correct? And particularly it could be an issue with snapshot-based backups.
The question is, are snapshots supported on fault tolerance? And the answer to that question is no. They are not supported as of today.
Yeah, we have, so it's not supported with fault tolerance today. We're working on that, but we have some workarounds that, we have KB articles that talk about how you can take backups of your FT VMs. There's several different ways to do it. You can use the templates, and you can also use storage snapshotting that's provided by your storage vendor to actually take a snapshot of the VMDK files and register those files to another ESX host, to another VM. Don't turn on FT for it, and you can actually take a snapshot or use VCB on that other VM. Right. So
the question is PV SCSI driver supported the fault tolerance? I'm sorry. Okay, she's R&D manager.
And 4.1, FT is supported with PV
and she's
SCSI.
saying it's supported with 4.1, so it should be supported with 4.1.
Sorry.
I'm sorry.
Right, so it doesn't, 4 for 1 gig. We're doing some more studies to, if you increase it from 1 gig to, something higher. It doesn't exactly scale linearly, but that's something that we're kind of working on. But the only recommendation we have so far is that 4 FTVMs on a 1 gig link.
2 gig support connection, would that be 6 maybe?
And again, it's really heavily dependent on the workload. So we're saying 4 for most typical workloads. But again, you have to look at the amount of traffic that your workload is generating. Something with very high disk I/O is going to require more. It's going to saturate that network more. So. Right. The question is, if you turn off FT, will the shadow copy go away? Yeah. If you turn off FT, the shadow copy is just it disappears, and when you turn FT back on, it'll create a new clone of that VM, and that becomes your secondary on another. You migrate on another machine. Automatically migrates on another machine.
So the only cost is CPU and memory, or you're doubling that CPU and memory requirement or resource in the cluster, but not disk. It's just CPU memory.
Right. So the disk, the primary FT VM and the secondary FT VM share the same VMDK file or files, and right. So it's about doubling of the memory and CPU. There's a little bit more that's needed on the primary side to do the actual recording of the non-deterministic instructions, and you need some network resources to send all that data over the FT logging network.
And physical RDMs are not supported, but it's virtual?
Virtual RDMs are supported with FT VMs. Denny.
Were you able to at least comment about the SMP support?
Oh, you walked in late, huh? What's the answer there, folks?
Future release.
We're working on it. It's oh, fall. Oh, okay. So Stratus, huh?
Is it?
I don't know, actually.
I don't know. So you're saying the multiprocessor virtual machines can make use of hardware fault tolerance?
So on your stuff, basically. Right. Yeah. Right. Right. So, yep. Right. Question?
If you've already provisioned two CPUs for your Exchange server, and you reduce the number of virtual CPUs on your VM, is there any lagging data that will prevent all from running on it?
I actually just did that in our booth, and it worked. So you shut down the VM, you move it down to one CPU, turn it back on, and the HAL should recognize that and switch it to a unit processor. Going up, I think, is different, but going down is okay. Yeah.
One of the challenges in multi-CPU support that I remember hearing from a hard manager one time that there's going to be at least two CPU, and now I feel like only one. What was the challenge and why it's so hard to do multi-CPU? Is it the scheduling?
It's really hard problem to solve. I mean, just to give you an example here, just imagine like two processors writing to the same memory location at the same time. Now, how are you going to record the sequence of these operations, and how are you going to replay it on another host? Then what it boils down to, you have to serialize them, and if you serialize them, it's no different than uniprocessor virtual machine. So record replay with a multiprocessor is feasible, but may not be efficient.
I think, and if we use the same method we use now for uniprocessor with SMP, and correct me if I'm wrong, but I think what happens is that you have to copy the memory over like 1,000 times a second over that the entire memory over 1,000 times per second over that FT logging network. So it's just a huge amount of network requirements.
Right.
You have there's this affinity rule you're talking about, basically keeps the FT clone, on a different host, and if you migrate that primary to the host where the FT is, it will turn around and migrate the FT back out somewhere else.
So.
You just confirm that? I think that's what I heard from you. And then also, you have to have your DRS on fully automatic DRS for any of these features to work, or can they work on level like 3 DRS? Yeah, so that's kind of the same thing, I think, if I'm understanding correctly. So when you create the FT clone, it creates it on different ESX hosts. If you then, what happens, for some reason, migrate manually,
It'll prevent you. Right. There's actually an anti-affinity rule between the prime and the secondary VM. So if you try to just move it to the same host, it'll just pop up a window and it won't let you do that.
so you would have to turn off FT, migrate the host, turn it back on, and then create it
Well, if you turn off FT, there's no more secondary, so you're not conflicting with anything. Yeah, right. Right. And the DRS question, I mean, DRS is fully integrated with FT, so you can have DRS set on any level and it would function the same. Yeah.
I'm just kind of thinking out loud. If you add hardware to a primary, would you need to reboot it for it to be seen on the secondary?
We do not support adding hardware at the runtime on FT virtual machines. Yeah.
Other questions? Yeah, all the I/O, all the input, all the network input to the primary is being sent over and replayed by the secondary. Sorry? Right. So vMotion is a separate network, and one of the best practices I actually didn't mention was so you needed a dedicated FT logging network and ideally a dedicated vMotion network, but you can actually NIC team those together and use the other one's NIC as the passive. You know. There's nothing that goes over there.
Yeah, I mean, the first to create a secondary. So basically, the way we create secondary is using modified form of the vMotion. Secondly, even for failover, then when you create a new secondary, when you reprotect the primary, again, you recreate the secondary using modified form of vMotion. Sure, this is the last session. We can take, they are going to throw us out, we can take some questions.
Changes over to the secondary, you could in theory take it a snapshot of those and be able to have a point in time, right? You can say at this point, these changes happened, they corrupted the database, so I'm going to roll my machine state back and play back these logs.
Yeah, that's a good suggestion.
That's a good suggestion. That's probably, I mean, I'm not working on that project, but it's something maybe that they're thinking about doing.
Yeah, and right now, the current FT, uniprocessor FT, uses a shared disk. With that implementation, it may require to use a different disk because you're lagging behind too much, maybe.
Early on, we talked about the benefits of it. I kind of got the impression there's a little hint of half a percentage possibly that there might be disruption. I didn't hear 100% it'll be no outage. Are there any conditions that you would see disruption?
100%.
No disruption, no outage.
Yeah. You won't lose any data, you won't lose any transactions, you won't lose network connections.
If there's a little quiver in our voice, we apologize for that. Yeah.
As I understand it, there's just a slight delay and it's basically failing over to the other fault component.
Right.
Sleep and resuming.
From the user's perspective, it looks like a vMotion has just occurred.
Yeah, exactly. There's like a new ARP call to say, hey, I'm over here now.
Yeah, it will send our packet to announce, you know what, I have changed the host location. So basically, it will, accordingly, all the clients will know the guest has changed the location. You're right.
If I understood correctly, you didn't recommend fault tolerance on virtual center servers. Are there other types of servers or roles that you're not recommending that I think?
So one thing is pretty clear. Whoever uses multiprocessor, you cannot use fault tolerance. Virtual center uses multiprocessor.
Assuming it's single processor, assuming it's not provisioned in.
Any uniprocessor VM can protect that
Yeah,
too.
and in short, like if you look at the workload we studied, we mostly studied all the enterprise workloads like SQL Server, Exchange, Oracle. We work pretty well. But if you talk about netperf, you may not see you will see bigger performance hit because it's sending too much of network traffic there. So, and network traffic is inputs and outputs. So the performance, you might see the worst performance for netperf with FT enabled, but you don't use netperf in production.
So if you're capturing all the port, all the inputs and the like of interruptions, certainly sometimes in say memory, something just bugs out, right? There's sometimes when the software crashes, something happens. Is there room here then, if you're only catching inputs and interrupts, that your secondary might behave and create a bug or something inside?
So memory corruption is a result of executing the sequence of instructions, right? And the same instructions will be executed on the secondary, so you will see the same memory corruption on the secondary. Right, because we are replaying what has been executed on the primary. So sequence of instructions which led to the memory corruption, same sequence will be replayed, and you will see the same memory corruption on the secondary.
But as Prashant mentioned earlier, there's a HA. If you turn on VM monitoring, HA will detect that the guest OS, you've lost the heartbeat coming from VMware tools in the guest OS, and then it'll initiate a restart of that VM. And after it does that, FT is still in place. It'll just create a new secondary on another host.
There's also, there could be a divergence for something weird happens on a hardware level on a secondary, and we'll actually catch that and say, oh, wait, the secondary has something else done than what the primary has, it'll just not be secondary, it'll just throw itself.
All right, thank you folks for coming to the last session.
Thank you.
Good luck.
Thank you for coming to VMworld.
Yeah.